Hi. In the previous slide, we discussed about the refrigeration and detailedly about the vapor absorption cycle. In this slide, we will discuss about detail about the magnetic refrigeration. Magnetic refrigeration is a cooling technology based on the magnetocaloric effect. The magnetocaloric effect is a magnetothermodynamic phenomena in which a change in temperature of suitable material is caused by exposing material to the changing magnetic field. In magnetic refrigeration process, hi, in the previous section, we detailedly discussed about the refrigeration and vapor absorption cycle. In this slide, we will discuss detailedly about the magnetic refrigeration. Magnetic refrigeration is a cooling technology based on the magnetocaloric effect. The magnetocaloric effect is a magnetothermodynamic phenomenon in which a change in temperature of the suitable material is caused by exposing material to a changing magnetic field. In magnetorefrigeration process, the steps of thermodynamic cycle are adiabatic magnetization, signed is isomagnetic enthalpic transfer, adiabatic demagnetization, isomagnetic entropic transfer. The first we'll see the adiabatic magnetization. In first step of cycle, a magnetocaloric substance placed in a insulated environment, externally applied magnetic field increased. This causes the magnetic dipoles of the atoms to align, thereby decreasing the material's magnetic entropy and heat capacity. Since overall energy is not lost, therefore total entropy is not reduced. The net result is that the items heats up T plus delta T. The next isomagnetic entropic transfer, in that added heater can then be removed by a fluid like water or helium. Magnetic field held constant to prevent the dipoles from the reabsorbing the heat. After a sufficient cooling, magnetocaloric material and coolant are separated. And the next is adiabatic demagnetization. In this process, the substance is returned to another adiabatic condition. So total entropy remains constant. Magnetic field is decreased. Thermal energy causes the magnetic moments to overcome the field and sample cools. Adiabatic temperature change. Energy changes from the thermal entropy to magnetic entropy. The next is isomagnetic enthalpic transfer. In this, the material is placed in thermal contact with the environment being refrigerated. Magnetic field held constant to prevent material from heating back up. Because the working material is cooler than the refrigerated environment, heat energy migrates into the working material. Once the refrigerant and refrigerated environment are in thermal equilibrium, the cycle continues. Components required for the construction: the first is magnet, and the magnet are the main function element of the magnetic refrigeration. Magnet provide the magnetic field to the material so that they can lose or gain the heat to the surrounding and from the space to be cooled respectively. The next is hot heat exchanger. The hot heat exchanger absorbs the heat from the material used and gives off to the surroundings. It makes the transfer of heat much effective. The next is cold heat exchanger. The cold heat exchanger absorbs the heat from the space to be cooled and gives it to the magnetic material. It helps to make the absorption of the heat effective. Drive provides the right rotation to the heat to rightly handle it. Due to this, the heat flows in the right desired direction. A magnetocaloric wheel, it warms the structure of the whole device. It joins both the two magnets to work properly. The next is applications. Yeah, applications will be a rotatory AME liquefier. In this, the cryofuel systems group is developing an AMM refrigerator for the purpose of liquefying the natural gas. A rotary centrifugation is used to move magnetic material into and out of superconducting magnet. This technology can also be extended to the liquefaction of hydrogen. The future applications may magnetic household refrigeration appliance, magnetic cooling and air conditioning in building houses, refrigeration in medicine, cooling in food industry and storage, cooling in transportation, cooling of electronics. Advantages of the magneto refrigeration is high efficiency, reduced operating cost, compactness, process reliability, low. It have low capital cost. However, it possesses some disadvantages such as the initial investment is more as compared to the conventional refrigeration. The magnetocaloric materials are rare materials, hence their unavailability also adds up to a disadvantage in magnetic refrigeration. Permanent magnets have limited the field strength. Temperatures changes are limited. Multi-stage machines lose efficiency through the heat transfer between the stages. Moving machines need high precision to avoid magnetic field reduction due to gaps between the magnets and the magnetocaloric material. Conclusion: it is a technology that has improved to be environment safe. There are still some thermomagnetic histories problems to be solved for the material that exhibits the MCE to become really useful. Magnetic materials available for room material magnetic resistance are mainly GD-GDLIs, perovskite like materials, excellent behavior of refrigeration and a heat transfer required. It can be used household refrigerator, central cooling systems, room air conditions, and supermarket refrigeration applications. This technology must be universalized worldwide. Thank you.